turbine is the quintessential backbone of the entire electricity generation process. The entire mechanism is a tandem compound machine, which means the three major components work in unison to rotate a single shaft that in turn rotates the generator to generate electricity. Following the actual course of action, we first arrive at the high-pressure turbine. This is a single-flow cylinder with 17 reaction stages, specially constructed to handle the immense pressure of steam as received from the boiler. The outer casing of the HP turbine is like a strong barrel. This particular shape and its rigid structure allow extreme flexibility of operation. It gives immense pressure-taking capabilities to the turbine, a critical skill to have because the turbine is constantly subject to short startup times and high rate of change of load at high initial steam conditions. The inner casing is axially horizontally split and is supporting in such a way that it can freely move, thus counteracting thermal expansion. This is the same reason why we see gaps in bridges and railway tracks. Next in command is the intermediate pressure turbine, more commonly referred as the IP turbine. While the inner casing of the IP turbine is also split like the HP turbine to accommodate thermal expansion, the similarities end there. The IP turbine is a double-flow construction turbine. Steam enters the inner casing from the top and the bottom and is split in the middle to turn the blades, which are a total of 12 blade stages on either side in number. Lastly comes the low pressure turbine or the LP turbine. The casing here is a triple shell design, the shells being horizontally split and welded rigidly. The innermost shell, which carries the first three rows of the blade stages, does however have mobility to account for thermal expansion. This first initial rows of blades is similar to the stationary blades of the HP and IP turbine, but the last two stages of the LP turbine are fitted with twisted drop-forged moving blades with filtry roots. These engage into the grooves in the shaft with the last stage stationary blades that are made from sheet steel. The residual exhaust steam from the LP turbine is connected to a condenser where it gets converted into condensate. This three-part construction is supported at various intervals by on bearings, ensuring as frictionless rotation of the central shaft as possible. These general bearings consist of an upper and lower shell. In order to prevent the bearing from exerting a bending pressure on the rotor, it is pivot mounted in a spherical support. This time and tested construction of the turbine ensures maximum efficiency and minimal breakdown time. There are two such units, each of 490 MW in Dadri Thermal Stage 2. The Stage 2 setup collectively generates 23.52 million units each day, accounting for a total 37% of the entire NTPC Dadri power plant.